All right, everybody. Good evening. Let's get started on should be a very entertaining video and probably going to make some heads explode, and I'll get into that in a minute. How to set up and machine the end of a block square, and I've got three different methods I use for this. You get this piece of steel. Like I had to do these little blocks at work today. They were 4 by 5, and they were 2 inches thick, and the ends were saw cut. So they cut it out of 4 inch stock, 1.5 inch or 2 inch stock, and whatever, but the ends were saw cut. And I've got different options to do that. Now, I could certainly put it in the vise and run an end mill down the side, but they decided to try something different today. So this is the first method out of three, okay? And I'll go over the other three as we move along into new videos, not in this one. So I decided today to pull out this guy. This is a magnetic cylinder square. It's a precision instrument. You can see how lapped in and shiny it is, but the secret to this is at this end. The secret is this end. That's a magnet, all right? So this particular surface here is totally perfectly perpendicular to the shaft, all right? 90 degrees, perfect, okay? Within millions, all right? You pay for that. We'll get into that later. So let's take a look at this piece of steel that I put in my mill. So I've got my magnetic cylinder square here, and I'm just going to indicate that back and forth, tapping this block. I've snugged up the vise slightly. There's nothing under the piece. Usually I tip it back like at 5 degrees and just slowly hit this side so I have room this side with my indicator, okay? I hit this side, the left side, and just keep tapping it in until this reads 0, all right? So let's see what that looks like. So there you go. The magnet's stuck on the side of the block, and I'm just indicating it back and forth until I get a nice 0 reading. That's what the setup looks like, okay? So then we go to the next slide here. What do we got? Well, then we take a skim cut, okay? There's nothing underneath this. This is a Kurt vise, so it's nice and tight. And I just touched this, and I think I took off about 10 thousandths. Now, here's a little bit of a bonus for you guys. 3-inch face mill here. It's a nice Iscar. Does a nice job. I've had this in my machine for 15 years. Fresh inserts. The reality is, when that thing goes across here, no matter how fresh those inserts they are, when that end mill, that cutter exits, I believe it drops 0.5 thousandths anyways. I've never proven that, but once the pressure comes off the full cut, it drops a little bit. If you really want this flat, you take small cuts with a smaller end mill. We're not in that position today where everything has to be perfect, okay? So we're not going to worry about that. So the next step is, after that's done, to check it for squareness. So we're going to use the same gauge on the surface plate. So now, okay, I've got that set up on my magnet with the surface gauge and my indicator. What do we got here? 0 at that end. Sorry about the glare. Let's get rid of it. Okay. 1.5 thousandths out of square. Not too shabby for a milled cut. All right. That's a pretty decent sized piece of steel. We're good with that. I can totally live with that. And nobody's going to check the squareness on this anyways. But now is what we're going to do is 15 years ago when I started posting this method, a lot of brains broke. A lot of people had to take a knee. I don't know if they've ever forgiven me yet. What I've got here is a Starrett surface gauge here that I have literally sliced a slot in here and put this little plate on here with a radius. That radius doesn't have to be totally precise. In fact, you can belt sand that radius on there. But what we're going to do is rock that indicator back and forth until we find the high spot and then check the other side. Now, if my calculations are correct, based on my beautiful magnetic cylinder square, here's how this should look. If my magnetic cylinder square said I was off 1/1000, when I use this method, this block should be totally out of square by 3/1000. So if you're looking at my hands down the corner right now, if that block is like that or like that, we already determined it's 1/1000 out of square. So when I check the other side, it should be another 1/1000 out of square. One side, they're both going to be out of square, one way, facing one way or the other. So our total out of squareness should be 3/1000. And by accident, I proved my theory today. So again, what we're going to do is rock that back and forth. Again, that radius, I didn't belt sand it, but you could. It's always going to find the high spot, all right? So let's watch this one. So here I am. Got my indicator base here. Watch this now. I rock it back and forth. I set a 0, all right? Or 0. Now, we turn that same block around. It should be off 3/1000, 1/1000 per side, according to my magnetic cylinder square. 3,000. Oh! And that's why I'm the tool and die guy, all right? You know, I have to say, for many years, I squared up a lot of blocks. And the reality is, in the injection mold industry, you've got this giant mold frame, right? And the guys that you know, depending on the material, they might want the molding area, the inserted area, hardened. So you don't want to pay for a hardened mold frame. So you build a mold frame and you cut a pocket in it, and then you square up inserts. Now, that's a small block of steel compared to what I was used to working at. Let's say I have a 12-inch by 12-inch block. And you can look down here at the screen. Big block, foot square, 6 inches thick, all right? And then I'm going to machine a pocket in a mold frame 6 inches deep, and I have to know how to make sure that's square, right? I have to have nice sharp end mills. That's a whole different story. And then I got to square up these blocks so they fit. So if I cut a 12-inch pocket, I'm going to make it a thou big per side or maybe total, and then the insert needs to drop in. If I'm not square, that thing's going to go halfway down and get stuck, and I am screwed. I have to take the mold apart, flip it over, bang it out. We learned how to square stuff up. So I'm telling you, that method right there is how we did it, all right? Again, everybody freaked out 15 years ago, but 15 years ago, I used to take things a lot more personally, and now I don't. So I know that's the right way. So there's a couple other ways to do this, to square up a block in a mill. It's weird in the machining industry. We don't really get called out for squareness a lot, but it's just in my head. When I'm going to build some fixture blocks, they got to be square, within reason, okay? And the reality is, nobody's going to check them for squareness. And the double reality is, I think I'm the only person in the entire plant that knows how to properly check something for squareness. If you guys want to get one of these, looking at a couple $100, all right? Don't buy one used on eBay, because God only knows what somebody has done to the perfect end, all right? It's worth, in this opinion, I will buy a lot of stuff used. This particular piece, you probably want to buy brand new, so it's certified and you know that's square. I actually have a rubber end I put on mine when I store it, because if that end gets dinged or people start stoning it, you're losing that perfect 90 degrees, all right? So that is a gauge. I'm the only one in the shop that has it. I have it. My QC department doesn't have it. But again, we don't check a lot of squareness there. So I will go over that method. I'm sure there's going to be a lot of questions on this, and I will teach you guys what we're doing there. Hopefully most of you guys got it. I'm sure a few of you guys will have to take a knee, and I'm sure there'll be a lot of questions. And I know that my old timers will say that's exactly right. So once again, I am Phil Kerner, the Tool Die Guy, broadcasting from the snowy Erie, Pennsylvania. Another 7 to 15 inches scheduled here. And I'm not talking about metal. I'm talking about snow. So we'll see you on the next video. Thanks for watching.